Hello, everyone. Welcome to Learning Activity 9 Lab for this week. And this is a follow-up to Learning Activity 8 about extending our AI architecture. So in this lab, I'm going to go ahead and jump straight over to Google Colab. I've got it pulled up. And this is the Python notebook that we've been working with. So we've already done a little bit of software engineering on this in our session 1 lab that was earlier in the semester. And as well as session 2 lab, where we actually got into a little bit of machine learning engineering work by spinning up the large language model. And so in the first one here, session 1 lab, the Python primer, right? We just did just a high level. Let me run through these just to kind of get everyone back up to speed on the labs and where we're at. So the first one, we did a Python primer, went through Python variables, high level Python syntax, differences between line comments, block comments, spinning up some Python variables, as well as the data types as it relates to Python variables. We created some simple programs. We also did some programmatic control flow, just if else statements, and then we talked about operators and Python operators, and that pretty much rounded us out for a quick Python intro. And then switching over to session 2 lab, we actually came into working with Hugging Face and the DALL-E large language model. We worked with the 3 billion parameterized version of DALL-E. So we shelled out, did a pip install, and pulled in the transformer as well as a couple other libraries, Accelerate and Torch. And then we went through and leveraged those libraries. We did a Torch import, and then got our pipeline going, and then we got to generate text variable where we pulled the Databricks DALL-E v2 3B into that pipeline, and then we actually created a prompt. We did a test prompt, and then from the test prompt, we created a more interactive prompt. And from that interactive prompt, that pretty much rounded out. And if I'm going to come up here, that pretty much rounded or completed session 2 and the last set of labs that we've done. So now we're going to go and do another lab. Now, this would be technically lab number 4 because we did a lab for prompt engineering on OpenAI. And the reason I used OpenAI is because I wanted a large language model that was highly parameterized, or hyperparameterized is the way I would call that. Something that it's got a lot more horsepower behind it versus the smaller large language models we've been working with, which are tiny in comparison to what OpenAI is working with, but still very, very usable. So anyway, we had that third lab that was based on the prompt engineering, prompt design and prompt engineering. Excuse me. And we went through the techniques of prompt design and good prompt design. And so that would be our third lab, but this would be our fourth lab in total, but our third coding lab. And so let's go ahead and jump into a text block and here, and we'll probably go and we might have to go through and struggle a little bit with some coding pieces here. I'm going to rerun some code from the prior session that we had just to make sure that this is all up and running. And then I'm going to go ahead and create session 3 lab, AI system architecture. So session 3 lab, oops, AI system architecture expansion. Wow, can't spell today. Expansion. Okay. And for this one, we're going to bold it, and then we're going to make it larger, and then that looks good. Okay. And then from there, we'll create a code block under that. And let's go ahead and I think all of this from my prior session, you may have to rerun session 2. So I highly encourage you to do that. So in other words, open session 2 up, and then rerun this code, and then rerun this code, and then you'll rerun that code. And I'm just gonna check this. Oh, it looks like my session went offline temporarily. So if I rerun this, I should be in good shape. So I'm going to go ahead and rerun mine. I'm going to pause, and then I'm going to come back when this is done. All right, I'm back. So my session timed out. I had to redo. I had to go back from the beginning. If this happens to you, just for your information, you don't have to rerun the session 1 lab, because that's just the Python primer. You only have to restart with a session 2 lab, so you can, and you don't even have to do this step here. This is just a test step. It prints the Hugging Face Databricks Dolly LLM HTTP link. That's all it does. It doesn't actually execute any code, but it's good for testing purposes. So I run it just for kicks, and just to make sure that I get a return. But our second line, the pip install must run. So I had to rerun that. I got a clean install. I'm currently running through our code to get the pipeline back up and running for Dolly V23B. And then I'll get a generate text variable, which will have I shouldn't say just variable, it's our object. The generate text object becomes our large language model at that point. So it's downloading. I did make a minor adjustment just while this is getting installed for people that are looking at the comments here. You may have noticed that the read Dolly LLM into variable generate underscore text. I made some additions here. So there, if you go out to the huggingface.co Databricks website, you'll actually see you'll see a base version of the LLM, an instruct version, and then you'll see a lot of these others out there. There's actually a 7B. I mentioned this briefly. I haven't worked with these yet. They're larger models. And 7B, I want to say is closer to 13 gigs, so it's a much bigger model. And I don't know if there's enough RAM on our session to handle that larger loading that up into memory. So in the 12B version, if you just kind of follow the path, right? If 3B is 5.8 gigs, which is the bin model here, 5.68 gigabytes. And then you're looking at 7B, which is a twofold increase. The Torch model is going to be quite a bit bigger. It's going to be 13-ish, a little bit more than double. And then so then the 12B isn't going to be quite double, but you can expect it to be in the easily in the 21 to 22 gig range. So it's much bigger, and for us to for us to load a 13B, or excuse me, a 12B or a 12 billion parameterized model, we'd need a pretty significant increase in the RAM to make that work. And so if you do, and this is just for folks that have a much bigger video card or the RAM capability, you could test that out. I throw that in here, this Dolly V212B. If you took this code and ran it locally on your machine, you can build all of this locally and run this all out. And if you have the architecture to support that, you could probably get away with running 12B. It's a significant jump in intelligence between 3B. The 3B model is pretty smart. 7B, of course, is smarter, but 12B is a significant jump in reasoning, logic, and intelligence capabilities. So anyway, something to think about. So, but for our lab, you're good to go. I've got a clean run on this one. I'm going to go ahead and get a res. I'm going to run this again. This is a test run. This is a hard-coded test run just to make sure that the Dolly version that we have, the 3B version, is going to work just fine. And it did. It was able to differentiate between nuclear fusion and fission. So did that just fine, was able to give us a base output. I'm going to do the prompt here. This was getting us back to, yep, and our prompt is working again. And I think last time we said, describe the difference between apples and oranges. And this is just for testing purposes. So we'll run this, we'll pass the prompt to our large language model, and then it gives us a nice output. Says our machine learning model that we spun up says while both apples and oranges are fruits, they have vastly different characteristics. Apples are sweet, delicious fruit, whereas oranges are acidic and are commonly used remedy for lack of vitamin in a diet. And it kind of gets some stuff wrong, right? It says oranges are not sweet, but they are. I mean, so it's kind of an interesting take. So it says, however, oranges are better for your health due to vitamin A. Okay, well, it's not the smartest of models, but it did pretty good for a small model that we've been working with. That's not too bad. Anyway, we're just testing it out, so we can actually stop our model now because it's currently running as a prompt, an interactive prompt. So we've got that spun up. We can actually go ahead and stop. Okay, now next up, this will be an interesting coding session because I'm going to try to use the features of the AI Gemini to help. So I'm going to use another operationalized AI in Google Colab called Gemini. It's this one over here. And Gemini has, for us, is specifically tuned for coding. And I've been coding for a while, and so everyone who's been around my lectures, they know from my time, I've spent a lot of time coding, and I gotta say, using Gemini to augment your coding it just makes your life so much easier. And I'm a big fan of it. So I do want to show off the capabilities of what Gemini can offer. And so I think that it's good for everyone here to kind of get a feel for what are the possibilities when it comes to that. Okay, so I'm going to create a coding segment past this session 3 lab. Actually, I've got one already ready to go. So start coding right here, but instead I'm going to say generate with AI. Now, I did this in a prior session to building out some of our one area. I had to augment it quite a bit. In this case, what I'm going to do is I'm going to be pretty general about what it is I'm asking for. So click on the generate AI link there, and specifically, we're going to be building off of this res. We're going to build an API interface off of that. So we're going to say, can you build a an API from the res variable from earlier? And so we're going to run with that and see what it does. Okay. So create API from res. And what's great is it created a API JSON object. So in the old days, literally, and I say old, like literally last year, I had to type this all out by hand. There was just no way to get around this. So if you wanted to create a JSON format, and remember what I mentioned in the prior lecture, in the prior learning activity, in that lecture, I mentioned that to build an API, or rather to build a JSON format, the JSON format is the process by which we standardize the data communication that occurs between the server and the client. So now, as it relates to what we're doing here, it created a standardized output for us, which is fantastic. And now I'm going to go ahead and just high level, we'll do a quick code review of what it did. So it's using a JSON Python library. So we did an import JSON, and then we created a function that def create underscore API from res. That's what's called a user defined function. And so res is the argument that gets passed into the function, and that's what we want, because res from here is what we're pulling from. And so that all looks good. And the rest of this is a string literal, and it's a block comment. It's just describing what we're doing, arguments and then returns. And then within that, I have an object called API underscore JSON. And this is the actual JSON format. Remember in the lecture, I mentioned that connective tissue, that API. Well, that's that API being the connective tissue and the JSON being the format. This is it's clumped together as API underscore JSON, and it creates the format for us, and then it does a JSON dump, and then we're going to do a print. So let's run this and see if it works. And I think high level, I think it works. I think we've got a clean version of this. Looks fine. We got a clean run. It actually did it beautifully. We didn't pop an error anywhere on this. Remember last time we did this, I had to augment the code real time to get it to work. And in this case, we didn't have to augment it. So this looks pretty good. Now, it doesn't look really pretty to look at because it just printed it out all on one string, on a single line, which makes it really kind of hard to not kind of, it makes it hard to read. So now let's use the AI to help us out. So that was a good clean run, and it created an API, a JSON API object for us. Next up, let's create another code block. So I went and hit code, and then I've got this start coding or generate with AI. So we're going to do this again. I'm going to say generate with AI. We're getting some good feedback from what's being developed here. So I'm going to say so we're going to use natural, just we're going to talk to it like we would normally talk to a human being. And so I'm going to say, can you now create a beautified version of the API JSON object? And now I'm going to double check to make sure I've got this right. Create def API JSON. Yeah, that because it's this print API JSON, that is now the output object that we are wanting to get a better feel for. How does it look when we beautify it? And this is kind of interesting. So we'll see what this does. I want to be able to get something that looks a little bit a cleaner output. So okay, so we're creating a import. We're doing a JSON import again, and then it's creating a JSON. Okay, so it's adding indent on this. Indent equal 4. That's fine. Let's just go ahead and run this. It's a lot of duplicate code minus the function. Minus the function. Okay, so that's okay. So let's go ahead and run this and then see what we get. Now that's pretty cool. So what happened here is, remember on the prior line, I just asked Gemini to build an API from the res variable, and it did that, and it did a fantastic job. And this is purely for coding purposes. It's not meant to be looking nice for a human to be able to interpret. So what I did was I said, "Hey, can you beautify it?" And then it did that so that me as a human has a better ability to read this. So and it did it good. It did a great job, and it beautified it and gave me a new object called a beautified API from JSON. Now, this one is not going to be something that we would use in an operational context. This is just more for debugging purposes. So we would actually comment that whole code block out in an operational environment. We would axe that whole bit of code and just work with the code above it. Okay, so let's just run through this and the output. Open API, info, Dolly LLM API, all looks good. We're working with the JSON. It gives us JSON description, content, schema, type, properties, generated text, type string. That's all that. That's a great output. That looks clean. So, so this is what a JSON format looks like, and this is the method by which we would communicate with um, with our machine, and doing it in an automated way. Okay, let's see. Next up, I think the last thing we want to do for this lab is we want to create um, a service. And so this is the part that I think is going to create some fun for us. And I want to stick to the exact prompt that created lots of errors. So let me go over to my code, and then so that I can get this prompt. So I'm going to get a new code block here, and we are going to generate this with AI as well. Again, we're going to use Gemini again to create a service that we can interact with. We won't be able to test the service out on this session. We'll work on that next week. This is just to kind of get the framework going, but I do want to get us to the point where we get a microservice up and running. So let me get that prompt here. So because I want to make sure that I get this specifically set up to error out, because I want to show what the back and forth, how the back and forth works between Gemini and what it is that we're doing. So I have to pause for a second so I can go grab that from my notebook here. Okay. So what we're gonna do is we're gonna go ahead and say, from the prompt that I was able to grab from my notes, we're just gonna say, now from the JSON, oops, no, we gotta say generate with API. There we go, generate from Gemini. So we're gonna say now from the JSON create an API. So we're gonna do this, and it's going to give us this, and I think it might have just given us the redone it, right? I mean, it didn't really give us anything new. So if you look back, it didn't quite understand what it was we were doing. Well, it understood what we were doing. We probably just didn't do a good job of explaining what it is we wanted. So we've got an error here. And I've got create an API object from the JSON. That didn't work. And then I can come in here, and this is where I wanted to get back into a little bit of back and forth with Gemini. So I'm going to go and explain the error, and it's going to tell us, hey, it's going to go think, it's going to come out here. Now we're communicating. This is what's fascinating, is we're now communicating with another AI to help explain our code error. So it's going to go and say, hey, it looks like we got load Python dictionary object directly to JSON loads. Function is designed to parse JSON, not an actual Python dictionary. So it thinks that this is the actual error, the issue here. So, and it's creating suggested changes. So let's go ahead and do this. We hit this button, and it creates a whole new line of code here. I'm going to close this out now. And this one we can delete. We can delete this one here. And we've got a new prompt down here. And let's go ahead and run this and see if we get anything else. This is back to the beginning, though. So this doesn't really give us anything extra, right? So if you look at this, I've got an API. It just created an API. So I didn't really bias anything by going this route. Because when I said, can you create a beautified version of the API JSON object, and can you build an API from the res variable? It's got all this in training data, so we basically asked it to create something similar. So we didn't quite get where we needed to go. Okay, and that's okay because I wanted to show off the error and question and answer to resolve the error. So we did resolve the error, but it didn't bias anything. So I'm going to delete this, and we're going to do this again, and then we're going to be a little bit more descriptive. So what we're doing is, remember, we're creating an operationalized environment for our large language model. So what we're going to do is I'm going to create a code segment again. So this is, we know that the beautified version of this works, again, just for testing. So we're going to create another code block under that. We're going to generate with AI, but this time, if our theme is operationalization of this, well, then maybe we should just say that, right? Maybe what we were saying is, okay, create an API integration. And then say let's say using the code in this notebook, create an API integration. And so that is hopefully more descriptive. So let's see what it does. Now it's going to scan through our code. It's going to say prompt using code in this notebook, create an API integration, import the necessary library. So we get a JSON. We got Google Colab, import files, and then f.write, beautified API JSON. This looks interesting. I haven't seen this one. And then it creates a JSON output, which isn't exactly what I'm looking for. So this is not quite right, because all it's now at this point, what's happening is it's taking the API and the data and then dumping the JSON file, and giving us an ability to do that. So that's okay. I mean, all right, it's not what I want. So I'm going to delete that again, and then we're going to create another one. We're going to come back, do some code, generate with AI, and let's just keep it simple. Create, let's go up here. But then we'll keep it simple, but pass in something that is that API underscore JSON. So what we're going to do is say create an API integration for the API JSON object. Okay. Let's see what we get off of this one. So now it creates a request, import request, creates a generate text API. This is not bad. I get a local host, generate text, create an API integration, start a local API server, using UVcorn. Okay, let's give it a shot. Let's run this and see what it does. Now, this created a host of errors. So let's explain the error and see what happens. But this is getting closer because we're actually getting, remember, server-client architecture. This actually is trying to create a server. All right. So the likelihood the API server you're trying to start, UVcorn, hasn't started correctly or isn't accessible. So now it says it gives us some code to work with. So we'll just go ahead and use that code. Let's run this code. So now it's going through and installing a bunch of stuff, all the missing pieces. All right, we're gonna let this run for, okay. Okay, this is interesting. So it did. So now that actually worked. It's still running. So it's actually running a server down here off of UV Corn running on HTTP 127.0.0.1 8000. Uh, so that's cool. That's actually unexpected because that wasn't one of the ones that I would have expected to work. Um, there's another one using Flask as a microservice that usually is the one that we would go with. But this is fine. It's actually working. I've got some code running, and we do have one small, there's an error loading in the ASGI app, but that's okay. This actually means that we're running along just fine here. So I'm going to stop this. I'm going to save this code, and then we're going to do one more to create a Flask object, and then we may have to just be more specific. But this is what's interesting is this saved me a ton of time just interacting with Gemini. I could have been spending a lot more time reading Stack Overflow, collaborating with colleagues, working through with my team or my software team, whoever it is that you're integrated with in your environment. It's a haul to kind of build all this stuff. But with Gemini by your side or any type of coding AI that can help augment your ability, it's huge. And we were able to pull some code out, test it real quick. This actually would go a lot faster if I'm not lecturing, of course. And I'm in, oops, let me pause that. And I'm in an operational environment where I'm just solely focused on cranking code out. Of course, this is going to go a lot faster. So I'm going to delete this one. I'm going to save this code. I like this one. I'm going to create another code block here, and then I'm going to generate API. Similar here. I'm going to say create an API integration. And we're going to keep that. Let's see if it goes in and tries to use Flask. This one didn't use that. So how about with Flask? With Flask. Let's see if it adjusts it. So this is what's kind of neat about this. Here we go. Yeah. Okay. So if we add the library, it went ahead and said it created that, imported the necessary libraries, and then there we go. So this is another clean install. So in literally just a few steps, I took the code that we had, said create API integration with Flask, and it created out the 25 lines of code we needed. It gave me the app route, created a function, and then spun up a microservice. That's what Flask does. And it gave me a clean run here down at the bottom. And that's, we won't test out we won't do this week. This is a good stopping point because I want you to be able to sit down and I threw a lot at you. There's a lot going on here, a lot of moving parts. So I want you to have some time to kind of sit down and run through this. And then what we're going to do is next week we'll work with interacting with these. Okay, so that's all I've got for today. And this week, if there's, of course, any questions, any ideas or any concerns you have, of course, feel free to text or email. But with that, we're done for the week, and I will see you next week.